the system, the velocity of m1 is v1, that of m2 is v2, and that of m3 is v3. So P system, that is the system which has m1, m2 and m3 as its constituents mass particles. So the P system would be sigma mi vi, which will be equal to m1 v1 plus m2 v2 plus m3 v3. Now let's see what is the center of mass of the system, that is system with these three particles. So the position vector of center of mass would be RC is equal to sigma mi Ri by sigma mi. This we have already seen. So if we differentiate this equation, we'll get Vc, that is velocity of center of mass, is equal to sigma mi, and again differentiating Ri, will get Vi by sigma mi. So sigma mi Vi is nothing but P system. So Vc is equal to P system by sigma mi, or P system is equal to Vc into sigma mi. So from this equation, that is P system is equal to Vc into sigma mi, it is clear that the linear momentum of a system of particle is equal to the velocity of the center of mass of that system into the sum of all the masses. So P system would be equal to Vc, that is velocity of center of mass, into sigma mi, that is m1 plus m2 plus m3. So if we know the velocity of the center of mass, then we can predict the linear momentum of the system even if we don't know the individual velocity vectors, that is v1, v2 and v3. So even if we don't know the value of v1, v2 and v3, but we know the value of vc, that is velocity of center of mass, then we can find out the linear momentum from this equation. There is one more thing. A frame of reference attached to the center of mass of a system of particles is called C frame. So if the origin of the frame of reference is at the center of mass in a system of particles, then that frame of reference will be called C. Now we will start the chapter Newton's law. Newton has given us three laws of motion, which we will discuss one by one. So we will start with Newton's second law. Newton's second law defines the force as rate of change of momentum. This law is also called the fundamental law of dynamics. So according to this law, the rate of change of momentum of a system is directly proportional to external forces applied to the system. So here, as you can see, that F external, that is external forces applied to the system, is directly proportional to the rate of change of momentum, that is dp system by dt. So here P system is momentum of the system. In the SI unit system, we choose the unit of force in such a way that the proportionality constant becomes 1. So F external will be equal to dp system by dt. So this is true for SI unit system. So continuing the discussion further, we know that the momentum of a system is defined as sigma m into Vc, where sigma m is the total mass of the system and Vc is velocity of the center of mass of the system. And sigma m is the total mass. So let's talk about a system with constant mass. So according to the Newton's second law, the external force applied on it will be equal to dp system by dt. So P system is sigma m into Vc. So F external would be derivative of sigma mvc by dt. Since the mass of system is constant, we get F external as sigma m into dvc by dt. We know that dvc by dt is, that is, derivative of velocity is acceleration of the system, so we get F external is equal to sigma m into AC. So here again AC is the acceleration of the center of mass. So the force applied on a system is equal to sigma m into AC, where sigma m is the total mass of the system and AC is the acceleration of the center of mass. Now let's get familiar with one more quantity, which is impulse. Impulse is defined as the product of force and the duration of its application. So suppose we have a force F external, and this force is being applied on a system. Suppose this is our system for a small duration delta t. So delta t is, this is the duration for which the force was applied. So we say that the application of this force on the system for a small duration delta t will impart some impulse to the system.